Welcome to today's tutorial. We also have other questions to look at on circle, the concept of circle geometry. On the board is also another question. Now we have an equilateral triangle of side 20 centimeter is inscribed in a circle. Calculate the distance of a side of the triangle from the center of the circle. Now, an equilateral triangle. So an equilateral triangle is a triangle whose sides are equal. All the three sides are equal. So it is inscribed in a circle. So we'll have a circle. Now we'll have the equilateral triangle. So let's say this point, this. Also have this point. So all the sides are equal. All the sides are equal. So of side 20 centimeters. So here is 20 centimeters. Here is 20 centimeters. Here too is 20 centimeters. It's inscribed in a circle, so we have inscribed this. So let's label this. Let's call this B. Let's call this one A. Let's call this one C. So they say calculate the distance of a side of the triangle from the center of the circle. Now we're going to apply different concepts on how to solving this. Now one of the concepts is going to be the theorem given that the angle at the center is twice that the angle that is at the circumference. So this is what I mean. Now let's look at this. Let's imagine we have a midpoint here. Let's have a midpoint. So if here is 20 centimeters, let's have here as M, our midpoint. So we have here, this is out of 90. So we have BM. So here is 20. So we have divided this into 2, this 20 into 2. So here will be 10 centimeters. Here will be 10 centimeters. Now, we have this. Let's consider an angle here. Let's find this angle. So let's call here theta. Let's say theta 1. Here too will be theta 2. So, but in this case, theta 1 is going to be equal to theta 2 because all the sides are the same. They are equal. So 20, 20, 10, 10. So theta 1 will be equal to theta 2. But let's look at this. So if I've gotten this, let's consider BM. Let's look at BM. Let's look at BM. So let's say we want to look at BM. So we have this like this. So we have this, we have this, we have this. So here is 20 centimeters, here is 10 centimeters. So this is M, this is B. So we're looking at BM. So let's say 20, or let's go straight. Let's say BM is equal to BM squared is equal to, here is A, is equal to BM squared is equal to AB squared minus AM squared. So BM squared is equal to AB squared. AB is 20, so 20 squared minus AM is 10 squared. So BM squared equals to 20 squared is 400. So 20 squared is 400. Now 400 minus 10 squared is 100. So BM squared is equals to 300. So BM is going to be square root of 300. So BM is equal to square root of 300. Square root of 300. That's 17.3 approximately centimeters. So 17.3 centimeters is for this BM. Now, we're done with this. And the next thing we're also going to look at is, let's look at this angle. Let's calculate this angle. Now don't forget they say calculate the distance of a side of the triangle from the center of the circumference. Now, so let's before we look at this, let's say we have a radius from the center to any part of the circumference here. So we have here, let's call here O, center O. So let's calculate this angle so that we can know what this O is. So we have, if we're considering this more of like this side, theta 1. So this is opposite hypotenuse. Opposite hypotenuse is sine. So we have sine theta 1 is equal to, theta 1 is equal to opposite over hypotenuse. So we have sine theta 1 is going to be opposite is 10 centimeters over 20 centimeters. Centimeter will cancel the other centimeter. So we have, this one have sine theta 1 equals to 10 divided by 20. This will give you 0.5. So we have sine theta 1 equals to sine inverse of 0.5. So we have 0.5 sine inverse to give us theta 1 is equals to 30 degrees. So this side is 30 degrees. So here is equal to 30 degrees. So here too will be 30 degrees. So the whole of this angle is 30 degrees plus 30 degrees, which is, so angle B is going to be 30 degrees plus 30 degrees, or better still, 2 times 30 degrees, which is equal to 60 degrees. So we have this angle B is equal to 60 degrees. So if I've gotten angle B at 60 degrees, to get this angle, the whole of this angle, we can get the whole of this angle. Angle O is going to be, angle O is equals to, we have a theorem that says angle at the center equals twice angle at the circumference. So therefore angle O is going to be 2 times 60 degrees, which is 120 degrees. So have the whole of this is 120 degrees. So angle O is 120 degrees. Now if angle O is 120 degrees and I can get this place and this place, so that means if I want to get here is going to be 60 degrees, here will be 60 degrees. So divide O by 2. If I want to get this or this, you just to say this, the whole of this divided by 2 to give you for this one and for this. So we have gotten this. Now let's call this place radius, which is our radius. This one is a radius. So don't forget what we are actually looking for. Calculating the distance of the side of the triangle from the center of the circle is this side we are actually looking for. This side, from this place to this point. That's what we're looking for. So let me erase this. So that means what we have is we're actually looking at this shape, this, and this. So here is R. We know here is 10 centimeters. This is 90. So we're looking for this place, which is 60 degrees. And here is W. Now, we can easily say opposite hypotenuse, but we don't know this place. We don't know the radius and we don't know this. So we are looking for this place. So our consideration is going to be opposite adjacent. Opposite adjacent, because this is what we are looking for, not the radius. Opposite adjacent. So we have opposite adjacent. Opposite adjacent is tan. Opposite adjacent is tan. So tan 60 degrees is going to be opposite. That's opposite adjacent. That's the formula for it. So tan 60 degrees is equal to the opposite, okay, 60 the opposite is, our opposite is 10 centimeters over, we don't know this. So what we're going to do, we cross multiply. So we have omega, or W rather, times this, W tan 60 degrees equals 10 centimeters. Now since we're looking for this, we have omega, or W rather, equals to 10 centimeters divided by tan 60 degrees, which is equal to, we have, let me erase this, have W equal to 10 over 10 centimeters over tan 60 degrees is equal to 1.732. 1.732 is what we have. So W equal to 10 divided by 1.732 to give you 5.77 centimeters. So this is the answer. So we have gotten this part. This is what we are actually looking for, this part. So I've gotten it as 5.77 centimeters. So it is calculate the distance of a side of the triangle from the center of the circle. So is this place we're actually looking for. I've gotten it as 5.77 centimeters. So thank you for watching. Do not forget to like, to share, and to subscribe. Thank you.